There we go. Consider the power series k x to the k over 2. Did these, you like these, remember? No? You didn't like? Okay, I'm mistaken. The limit as k goes to infinity of k plus 1 times x over 2 to the k plus 1 all over k over x over 2 to the k. Does that look familiar? Well, dig in then. And so you're going to take the limit as k approaches infinity of k plus 1 over k. And then what is x over 2 to the k plus 1? What is that? X over 2 to the k times what? X over 2. Sorry, Michael Jordan. All right, and then times x over 2 all over x over 2 to the k. Well, you can see that these are going to cancel out. What does k plus 1 over k go to as k goes to infinity? That goes to 1. So you're going to be left with x over 2. Now, this is the ratio test. All terms positive. And what it says is your answer has to be less than 1 to be convergent. So x is less than 2. And so that's going to be my radius. So radius of convergence equals 2. But my interval of convergence is going to be -2 to 2, but I don't know what those are. So we found the radius convergence. Are you ready to find the interval of convergence? Emma, you remember these? No? Okay. So you're going to take the limit, or we're going to let x be equal to -2, and then later on we're going to let x be equal to 2, so we can check this boundary and that boundary. Go into the original equation, you take the sum, k goes from 1 to infinity of k times -2 over 2 to the k. Well, what is that? That's like -1. So this is just going to be 1, and let's see, put a 1 in here. It's going to be -1 plus 2 minus 3 plus 4 minus ... Will that be convergent or divergent, do you think? Definitely divergent. It's going to do this. Boom, 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 boom. It's going to get more and more crazy. This one, the sum as k goes from 1 to infinity of k times 2 over 2 to the k. Well, that's just 1 to the k, so this is just going to be 1, right? So this is just going to be 1 plus 2 plus 3 plus ... And what does that do? Yeah, it totally diverges. So do you want to, here, I can show you another step here. The next step would be the sum as k goes from 1 to infinity of k. 1 plus 2 plus 3 plus. So neither of these are going to be included in your convergency interval. Yeah?
How did you get the -2?
Oh. Okay, so I took this formula here. Sum k equals 1 to infinity of k. And then it says what interval of x is going to be convergent. So we did this in part A, and we found that it's less than 2, so we know it's going to be -2 to 2, but we don't know which. These are my x values, so I just put an x. Instead of x, I put -2 over 2 to the k, which is the same as k times -1 to the k, and that's why it alternates. Yeah? I did that in part A. I took the limit. I did the ratio test. I got this x over 2 less than 1, and then I solved for x. X was less than 2, and so the radius, it's going to look like this on a number line. Here's -2, and here's 2. X is somewhere in here, and we don't know if 2 and -2 are included until we test them. Yeah.
You made some big huge equation that was only at k goes to infinity of k plus 1. Is that just the definition?
Remember, we had non-alternating, and we had alternating. We can just do this right now. Okay, the first thing that you do is you, for the non-alternating, just take the limit as n approaches infinity of u of n. What does it have to go to? First thing you try, 0. Okay, that's the definition. If it doesn't go to 0, there's no chance. If it goes to 2 or infinity, it's not going to converge. The second thing you do is the ratio test. This is what we just did. You say all terms positive, and then what you do is you take the limit, n approaches infinity of u of n plus 1 over u of n. If that's going to be your limit. If the limit's greater than 1, diverge. Limit is less than 1, converge. If the limit is equal to 1, can't tell. And then the third thing we do is the integral test. Okay? And the integral test has 3 things that you got to double check. One is all terms positive. You have decreasing and continuous on interval. Okay? And then we take the integral from a to infinity of u of n du has to be equal to some constant. If it's equal to a constant, it converges. If it goes to infinity, it diverges. That's it. Those are the 3. That, and that. That's the order I would do it, too. Now, we also had a comparison test. I'll let you look up that one. Now, for the alternating, all you have to do are 3 things. You have to make sure that the absolute value of those terms decreases. You can just say it, and you're fine. It has to be alternating somehow. Usually, it's -1 to the k. Usually what they do. And the third is you just take the limit as n approaches infinity. If that u of n equals 0, then it is convergent. There are no other tests. That's what Mr. Ludvigson's going to talk about on Monday night, if you want to come and see more of that. I just reviewed it in its entirety. Since I have you here, the 2 errors are for the non-alternating. The error is just going to be less than the integral from where you left off to infinity of u of n du, and then it's going to be greater than n plus 1 to infinity of u of n du. It's going to be between those 2. For the alternating series, the error is just going to be less than the next term. I love that. Oh, do I ever like that. Simple. Yep, Kurt? Here? You could use A for that, sure. A is a little bit better, because n changes, yeah, A. This constant. Is that good? So now let's finish this problem then. It says show that this series is convergent. Oh, you don't know how to do that, do you? You have no clue on how to do that, even though I said it in like 3 minutes ago. What's the only thing you have to do to test for alternating series? You just are going to say that the absolute value of u of n decreases on interval. You need to say that. And so what you could do is you could just list these. Here are what the terms are: 1/3, 2/9, 3/19, 4/33, 5/51. Are these values getting smaller? Yeah. So those are decreasing. And then just take the limit. As n goes to infinity, ignore the alternating. K over 2k squared plus 1, what's that going to be? K over 2k squared. That'll just go to 0. Therefore, alternating series converges by definition. And then the last part here, it says show that the sum to infinity of the series is less than 0.25. I thought this was a little weird, but you have your calculator on this. They took 1/3, found the sum. 1/3 minus 2/9 found the sum. 1/3 minus 2/9 plus 3/19 found the sum. And they just kind of listed these. And when you get to the fourth one, I have a sum of 0.148. And then the fifth one is 0.2458. Now, if you look at this, it's bigger, smaller, bigger, smaller, bigger. What will the next one be? Smaller. But what do you notice about the biggers? They're decreasing. Now, they want to see that they want you to show that the series is less than 0.25. And so what I did is I found these sums, and then I said, oh, once you get to the fifth term, the sum that's high is 0.2458. Will it ever get to 0.25? No, it'll always get smaller. So you can articulate that however you want, but after the fifth term, the high value is less than 0.25. Therefore, the sum will never get to 0.25. How about another one? For this number 12, what they're trying to get you to do is to tie probability distribution function with integrals. So we know that if you go from 0 to infinity of a e to the negative a x dx, what should that equal to? It should equal 1, right? But in this problem, they're not asking for that. They're saying, what if you have x less than 1? So in other words, your value up here isn't infinity. What is it? Yeah, this is going to be 1. And then you're going to figure out what that is. Oh, let's do it. Let's do it. This is the only variable is x, so we're going to have e. And then the constant is negative a, right? Well, here, let's do this. Let's do this. U is negative a times x. What's du? Negative a dx. Now, do you have the a? Yeah. You don't have the negative, though. So this is going to be the equivalent of e to the u du. All right? And so this is going to be negative. What's the antiderivative of e to the u? E to the u. Negative a, or alpha, x, going from 0 to 1. Okay? And let's see here, to 1. And, oh, okay. And they're telling you that it's equal, they know that it's equal to 1 minus 1 over the square root of 2. Okay? So when we put a 1 in here, I'm going to get negative e to the alpha times 1 minus a negative e to the 0, which is 1, is equal to 1 minus 1 over square root of 2. Do you see how the 1's cancel out? And so you're going to get negative e to the negative alpha equal to negative 1 over the square root of 2. The negatives will cancel out. And now you have e to the negative alpha equals 1 over the square root of 2. What are we going to do to both sides? Take the ln of both sides. See what I mean? Lots of algebra, not a lot of. So this is going to be negative alpha equals the natural log of 1 over the square root of 2. Yep, that's what we're going to get. Perfect. So then this is going to come here. This power comes up to here. So you're going to get alpha is equal to the natural log of, what is 1 over the square root of 2? What's the flip over of this? Square root of 2. Oh, wait. We don't want that. We want to get it like this. That's okay. That's okay. Alpha is equal to ln of the square root of 2. I like that. And this is the same as ln 2 to the what power? 1/2, which is the same as ln of 2 times what? 1/2. And that's what you're supposed to get. Or A. Mm-hmm. A alpha, yeah. For the median, you're going to go from, I think that one goes from 0 to the median of, and then I'm going to use that alpha. Now I know what alpha is, or A. It's going to be 1/2 natural log of 2, and then that's going to be e to the negative 1/2 natural log of 2 x. And dx. And then we're going to look at that. Median should give you 1/2. Yeah. So this is a, yuck. That's a lot of yuck to it. But notice that when you integrate this, a lot of this is going to cancel out like they did before. So I just wanted to give you that. That's the start or the setup for that. And you can look at the work that the key has. And then it says calculate the probability that x is less than 3, knowing that x is greater than 1. Okay? What's the intersection of 1 and 3? It's less than 3, and it's greater than 1. What's the intersection? The intersection is going to be the integral from 1 to 3 of whatever that was, f of x. And then knowing that this is going to be greater than 1, so it would be 1 to infinity of f of x dx. So they're turning that conditional probability into 2 different integrals. And I think you know this answer already. Well, maybe you don't. Yeah, it'd be 1 minus that, yeah. Yeah. So it'd be 1 minus 1 minus 1 over square root of 2. Well, isn't that just going to be 1 over the square root of 2? So you know what the bottom is. This one you'll have to evaluate. For number 9a, I think the tricky part here is knowing that this is just a substitution for a. That's all they're doing. So you start with 1 over 1 plus x squared dx. Okay? Wherever you see an x, we're going to substitute it with 1 over u. Okay? So for this one, this x here, that's just going to be 1 over u, 1 over u. So this is going to be alpha, which is going to be 1 over alpha, 1 over 1. This is going to be 1 over 1 plus 1 over u squared. Dx, we do have to take the derivative of this. What is the derivative of x? Negative u to the negative 2. So this is going to be negative 1 over u squared. Dx, the derivative of x, this is u. Yeah. This is x is u to the negative 1. Dx is negative u to the negative 2. Then what I did is I replaced dx with negative 1 over u squared du. I replaced x with 1 over u. And then what will happen is kind of interesting, is you're going to get 1 over 1 plus 1 over u squared times u squared in the bottom, negative du. So can you kind of see how I get this negative du over u squared plus 1? Can you see that? So we're done. We win. We got it. We got what they wanted. Huh? I got it. Perfect. Everything's the same except for one thing. What is it? Negative. Oh, start over. No. What does negative do to those boundaries? And does that work? We win again. Okay? Then this is like, I just love this problem. It's so cool. It's so cool. So then for this part here, show that this is what happens. All that you're doing with this is you're saying, what is the antiderivative here? It's the arctangent of x going from 1 to alpha. And then what are you doing here? You're saying that this is the arctangent of u going from 1 over infinity to 1. Or 1 over alpha, yeah, alpha. So this is just going to be the arctangent of infinity minus the arctangent of 1. I keep doing that infinity thing. This is alpha. And then this is just going to be the arctangent of 1 minus the arctangent of 1 over alpha. Right? Sorry about that infinity thing. I did that last night when I was doing this. So the arctangent of alpha plus the arctangent of 1 over alpha is going to be equal to the arctangent of 1 plus the arctangent of 1. And what is the arctangent of 1? Pi over 4, right? So you see how it gets pi over 2 equal to that? Way too much fun. Way too fun.